All right, welcome to part 2 of our how to model an object. In the first episode, we planned it out. In the second episode, just going to walk you through calipers here. There's a 3-part episode, or set of episodes on calipers, so take a look at that. I'm only going to do a brief review. Of course, you should always return your calipers, turn them off, back to where you found them. All right, so we did these sketches, and this is going to help us with marking our dimensions. And the Lego brick is really nice just because it's pretty straightforward, but also has some interesting features. Real quick in terms of I guess a style guide, the circle and slash, that means diameter. And often, let's say you have a rectangle, we have these sort of parallel lines, a little offset from the edge, and then, I kind of painted myself into a corner. Let's say this was 5 inches. So you sort of do an arrow. There's a whole official formal rules to follow, and these rules were very important. I guess they're still important, but they were especially important when CAD was stuck to a desktop computer, and then when you went out into the shop and made things, you had to rely on drawings. Nowadays, you have CAD software that you can pull up on your tablet, and yeah, it's just a lot more accessible. All right, so we've got our calipers. We'll turn them on. Now, often in engineering, we are working in inches, and I personally like to use inches. But actually, I know for Lego, millimeters is a little better. So, you can modify, adjust as you need. All right, as we know with calipers, make sure that your 0 is true 0. Open it up with a thumb wheel. This will tighten it up. Cannot move. Loosen it just a little. Okay, and then closes. Remember, we have 4 ways to measure on the caliper, so let's open up to a certain value, 29.35 millimeters. I'm going to lock it. Again, this is just review. 4 places. What is it? It's measuring between here and here, here and here. So we have outside, which is here and here, inside, here and here. Depth, okay, I'm not going to adjust the camera, between here and here. And then step between here and here. So let's just do a quick. We're not going to look at numbers, but just show you how you would use it with the Lego brick. So you have something like this, outer. All right, you kind of take a few measurements, take the average of it in your mind. Okay, you can measure that. So inner would be something like, let's say the circle. Actually, that's probably the best one here. See that? Or you could try to measure between those two. Then the depth is really good when it's a sort of hole and you're trying to measure the depth. So you see right here that where my left index finger is, that's one surface. And if we place it on the surface, I can use my thumb here, right thumb, put it down until it stops. And then I can get a reading. And the step, this is the hardest one to see. Think of step just as sort of a height measurement, but it's not a hole, so you have a lot more to measure with. See, so like that. So let me show you again. Boom. Okay, you could also measure it like that. That's fine too. All right, I'm not going to go through all of the dimensions. I'm just going to sort of walk through some main ones. And then when we get to a 3rd episode, which in this case we'll do an on shape, I will have already made the measurements, but it's still good practice for you to do so. All right. Feel free to pause here right now, spend some time on your own. You know our strategy here, make the measurements, and then come back to see how I go about doing it. All right, so I know these 8 circles. These are all the same diameter, 4.85. You make a few measurements, 4.87, okay? You just make your best guess. And again, you think back to critical dimensions, just make sure if there is a critical dimension that interfaces with something else, then you get that right. I don't know, I'm calling it 4.88. Why not? So I'm going to, I'll do a little, I like to do this curved call out. That's probably not proper style. And I did 4.88 millimeters. Okay. Again, I would like to emphasize my own personal preference with inches, and often in engineering we do inches. But in this case, because I know Lego, it's better to do the millimeters. All right. What else can we look at? Let's look at the height of the stud. So see if I can put this into picture here. Okay, 2.07. So you see here, here to here. Sometimes if it's narrow, then you can do this. 2.07 millimeters. Now, let's do bigger dimensions. Let's do this. I guess we could have done this minus this. That would have been fine. Yeah, lots of different ways to do it. So I'm going to do this, 9.54. So let's draw here, 9.54 millimeters. And of course we have the other dimension of the box on this side. .575, let's call it that. Again, these are not all quite to scale, but hopefully the distinguishing features of our object will help us differentiate. Jumping around here, let's go to the thickness. Thickness right here. 1.18. So here to here, draw our arrows. 1.18. And let's see, inner of this hole, kind of spin it around, call it 5.04. And I'm going to say inner diameter 5.04. Oops, not inches, millimeters. And the outer, a little harder to measure. We're going to assume all three of these are the same. Looking at 6.44 maybe. Yeah, sure, let's call it 6.44. OD. Not Garfield's dog, but OD. 6.47. Now you see here as I'm planning it out, if you have to write and then draw, you're gonna it's sort of, I don't know, I feel like that sort of loses your momentum. So that's why draw it out, plan it out, and then hunt for the information. Those 4 circles, okay, I mean, you can imagine trying to eyeball it. I'm just gonna skip that for now. 0.83. So, ooh, that's gonna be tight. 0.83. I don't know how proper it is, but if usually there's not a 0, I just call it 0.83. What else? Okay. So, can you guess the major thing we haven't talked about? So we've talked about the diameters of the circles, cylinders here, or the cylindrical cells. Outer diameter, inner diameter. We can assume this is centered, okay? So whatever the center is, that's where it is. But now we have to figure out the distance between. Now, this is a very important part where in real life, it's actually hard to measure the distances between 2 centers. Yeah, you see that? It's kind of hard. So what you end up having to do, you can do a number of things. I'm going to do this 3.10. And I have to be very careful here. Okay, this is where that big drawing would help. Okay, so if that's this, I wonder what happens if I do this, 13. I have to be very clear where I measured this. So you can see it's already kind of getting really messy. 13. All right, this one's trickier because you got sort of a shell. In this case up here, what's our assumption going to be? Our assumption is going to be the spacing. This spacing is the same, okay? And we assume there's symmetry from this side, okay? This side to this side, this side to this side. So what we're going to say is we are going to measure, how are we going to do this? We can do this many ways. I'm going to do similar to what I did down there. Is it the same? 13? I don't know. Will 0.14 millimeters make a difference? Let's just measure it. Okay, 12.86. So in this case, you don't have to distinguish the outer versus inner. That's 12.86. And then the inner here, right? And that makes sense that that would be a standard gap because this is just a brick by itself, but Lego is, you can sort of put in all different sorts of combinations. And there are official measurements online. That should be my last point as we finish off this episode. I don't know, 3.2. 3.2. And I'm going to assume that sort of the X and Y, in the X and Y direction, it's equal. And we know that just because the way that we put Legos together. All right, the last point that I want to drive home here, and I think I just lost that thought, is what? Let's see. So we talked about the outer and then the inner. And we said that we're making certain measurements, but we don't have to measure it each time. We assume a certain sort of pattern. So once we set that value, yes. Let's see, what shall we say? Specs. Specs. Specs, still can't spell. Specs from vendor versus measured. All right, dimensions. So we're reaching the end of this video. What do I mean by this? It's a balance. Sometimes you can just pull off a value from the vendor's website and see, oh, what is this spacing supposed to be? And that can be a help. That can be a good start, especially if you don't have the product yet. However, depending on what are the critical key dimensions that interface with other parts, you might want to actually measure. And that's because the tolerances, okay, are all going to be different in how the part is made. So something might be 3.5 inches, but they're going to say that based on manufacturing, it's going to be plus or minus, I don't know, 0.0001 inches or 0.005 inches. So in other words, and this is where manufacturing comes into play, when they make all these, let's say, Lego parts, they'll make them, but they'll have a quality control system to say anything that's 3.505 or greater, toss it. 3.495 or less, toss it. But if it's within spec, then that's good. And so what ends up happening is you have to figure out, especially if you're not talking about Lego to Lego, but different parts to other parts, whatever that interface, whatever the interfacing dimensions are, you have to prepare. And of course, with engineering, you won't know until you actually do it, but you can start with at least some initial information. All right, thanks for watching. You see how we need 2 episodes on paper just to do that first part, second part. Next episode, we're going to dive into Onshape. I will have already had measurements from before. I'm just going to walk you through step by step how to do it within Onshape. Thanks for listening, and we'll see you next episode.